You want to listen to the app.
Okay, algebra. First thing I want you to know, when you look at the assignment for lesson 5, it's going to say it's lesson 4. I messed up when I was printing them, so it says lesson 4 on there. Just so you know that, lesson 5 says lesson 4, but it's on these recursive and special functions. These are kind of interesting little functions because it's like the one I have here on the board. Yeah, I guess, you know, if I point up to the side there. I got a 1, a 2, a 3, a 5, an 8, a 13. That is a special sequence. It goes on and on and on forever. And there's a way to figure out how to get the next term. It's not arithmetic. It's not geometric, because I'm not adding the same number. I'm not multiplying by the same number. There's something else to it. And we say that it has a recursive formula, meaning to figure out the next term, I need more information to get to that. So let's talk about this one more precisely. The recursive formula for this one, if I can get that to work, there we go. Okay, highlight. Yes, note that error. Okay. So the recursive formula. What I noticed in this case is I can get a 2 if I add the 1 and the 1. I can get a 5 if I add the 2 and the 3. I can get the 3 if I add the 1 and the 2. So it looks like if I want the next term, n plus 1, I have to take the term I'm currently on and add the one before that. I'd get a formula like that. That's what we call a recursive formula. It says, how do I find the next term in line? Now, this particular one that I have shown here is called a Fibonacci sequence. It's one that you can find in a lot of different areas. One of the areas is like in conch shells. It kind of works out that way. So what we need to be able to do is we need to see if we can find the recursive formula for each of these problems. Now the first one, 5, 7, 9, 11, we can see that's very much an arithmetic sequence. I am just adding 2. So if I want to find the next term, my a n plus 1, what I have to do is I have to take my current term and just add 2. Now I can write it that way, or I can write it this way where, okay, the term I'm on is the previous term plus 2, whichever way you want to do it. Both of those are the recursive formulas for this arithmetic sequence. Let's look at the one that's 12, 6, 3. We can see with those terms that we have that it's geometric. We're multiplying everything by a half from the one before. So if I want to find the next term, a sub n plus 1, I'm going to take my current term and multiply it by a half. So I would do that. So to find the next term, I take the one I'm on and I multiply it by half. Or once again, I can say I take my last term and multiply it half to get the one I want. So let's take a look here at Mr. Yadzaksky. He discovered that there were 225 dandelions in his gardens on the first Saturday of spring. He had time to pull 100 of them, but by the end of the next Saturday, there was twice as many as he had left. Each Saturday in spring, he removed 100 dandelions, only to find that the number of remaining dandelions had doubled by the following Saturday. So if I look at this, if I want to look at the next term, I got to say, well, what happened this term? Well, however many dandelions I had out there, I minused 100 from it, and then what happened was it got doubled. That would give me the recursive formula to find out how many would be the next time out. Or if I want to go back to the other way, I would have it, my current term is my last term minus 100 times 2. So those are our recursive formulas. You might have to write some of those. The next thing would be, if it can get over there, is what if I give you a recursive formula and I want you to find the first 5 terms? Well, here it tells me I have the first term, A1 is 12. Now it tells me to find my next term, I take my current term and subtract 3. So if A1 is 12, A2 would have to be 12 minus 3, which would be 9. A3 would be 9 minus 3, which would be 6. A4, subtract 3 again. A5, subtract 3 again. I could continue this on forever. As I said, take whatever my last term was and subtract 3. So let's look at the next problem. My first term is 0. I want to find the next term by multiplying that by a negative 2 and then subtracting 4. So if A1 is 0, let me move this guy out of the way, A2 has to be a negative 2 times 0 minus 4, which would give me a negative 4. My third term is going to be a negative 2 times what I currently have, my negative 4, minus 4. Well, a negative 2 times a negative 4 is an 8, minus 4 would get me a positive 4. My fourth term, negative 2 times the 4, minus 4. So negative 2 times 4 is 8. Negative 8 minus 4 would give me a negative 12. And then my fifth term, again, I'm just going to take a negative 2 times what I just had and subtract 4. And I would get 20 on the nose. So there we have those two types of problems. What will happen is we start to get these really funky ones in that, put that up there for now. Here on this particular problem, I have my first term as A1, which is nice. A1 is negative 3. Now it tells me to find my next term, I take my current term plus the number of my term. So to find A2, I have to take my current term, which is the negative 3, add my current term number. Well, that's this number down here. So I'm going to add a 1. And if I do that, I get a negative 2. Now for A3, I would take my A2 number, so negative 2, and add the term number. Well, notice it was a 2, so it would be a 2 here. And I would put a 0. My A to the 4th, it's going to say I'm taking my third term, 0, and I'm adding the term number, which is 3. It'll be 3 there, so I get a 3. My fifth term, I'm taking my 3, and I'm adding, what is my, whoops, yep, I'm adding my 4, because that's my term number there, sorry. Here's my A sub n, here's my n, and I would get 7. So the next one would be 7 plus 5, and on down the line. Now, let's take a look at this last little problem here. See if I give myself enough room. Nope. Give myself a little bit more room here. Okay, so let's take a look at this problem. Notice this time we are given a first term and a second term, and our formula now says to find the term down the road. I've got to do these two things. So what that would say for A3, this would be A2. So 4 times A2 minus 3 times A1. So notice these numbers all go down the line. That's what's happening. So now I can take my numbers and put them in there. I know A1 is 1. I know A2 is 2. I know A3 is 4 times A2, which is 2, minus 3 times A1, which is 1. 8 minus 3 is 5. So now A to the 4th would be 4 times A3, which is the 5, minus 3 times A2, which is the 2. So now I have 20 minus 6. I've got 14. My fifth would be 4 times A4, which is the 14th, minus 3 times A3, which is 5. So I got 56 minus 15. I get a 41. So this one's kind of tricky in that it's starting with, okay, if I want a fourth one here, then this would be a 3 and this would be a 2. If I wanted a fifth one here, this is a 4, this is a 3. So we got to look, it's looking at the last two terms and doing stuff with it. It's kind of like the Fibonacci sequence in that regard. To find the next term, you got to go that way. Okay, this brings us to the idea of an iterate. An iterate is a special sequence. What it does is it takes the answer from before and it runs it right through the formula. So it takes a previous answer, misspelled that, and plugs it into the formula. So it's really a lot like what we did here. These were iterates, because all I do is take this number and plug it back into the formula that I had up above. But those got a little bit more complicated. So this first one. So x sub 0 is 3. So x sub 1, my first iterate, is what happens when I put a 3 into that equation. I get 3 times 3 minus 4. I get 5. Now my next iterate, my second one, I'm going to plug the 5 into that formula. So 3 times 5 minus 4. I get 11. Now my third iterate, I'm going to take the 11 and plug it in there. So 3 times 11 minus 4 gets me 29. And I will just keep doing that. All I want us to do for this part is just to find the first 3. So here I have found the first 3 iterates. I found the next 3 numbers after it. Well, let's look at the next problem. I'm starting with 1, and the formula says to square that and then add 2. So for my first iterate, I'm going to put a negative 1 in. There's a negative 1. I'm going to square that, and then I'm going to add 2. So that gives me 1 plus 2, I get a 3. So my second iterate, I'm supposed to take the 3 and square it and add 2. For my third iterate, I'm supposed to put an 11 in, square it, and add 2. I get 123. So all these are taking a formula and taking the answer from a previous answer and just plugging them in. That's all these iterates are. Now, some things that you're going to find out as we go down, we have a thing called an amortization. I want to ask your parents about that. Have they ever seen the amortization table for their home mortgage? You would have one of these for a car loan. All they do is they show exactly how much money would be in the account or that you owe, as well as what interest would be in and all. So all they are iterates. So there you go. There's your lesson 5. It is on the recursive and the special sequences. So special sequences being iterates or something along those lines. You're ready to go for the assignment. Recall, note, the lesson number is written on the paper as L04, but it's really the 5th one. Look for this terminology here on the title rather than the lesson number.